So I go on to say, instead of a hertz being used to control our pitch, i.e. from a number box being connected to our cycle object, or from an envelope generator like the function object, perhaps we'd like to use a keyboard. So we're using MIDI information and making that control the pitch and possibly the amplitude of our oscillator. So I've got a patch here that will enable us to do that, and it, again, it introduces, well, both one new object and an idea which you need to be familiar with or comfortable with in order to do that. But it's a fairly straightforward, I think. So in this case, we've got a kslider, which is, if I unlock the patch, it is this object here. And that, if I hit a key, is going to output, oops, I need to look at the patch, a MIDI note on the left-hand side and a velocity that comes out of the right-hand side. And notice that although pitch is being dictated by sort of x-axis, so from left to right, which makes sense considering we're dealing with keys, velocity is dealt with. If you notice, I keep hitting middle C and watch the changing number down here. If I hit it low down on the keyboard, it gives me low velocities. If I go progressively higher, it gives me progressively higher velocities. So in fact, the kslider does have a sort of XY axis to enable you to control both note number and velocity. So the note number comes out here, velocity comes out here. The note number goes into this object, which is M2F, is how you pronounce that, or MIDI to frequency. So it converts a MIDI note to number to an appropriate frequency. And it does that by means of a calculation which, if I go into its help file, you'll notice is quite long and complex, and you'll probably be quite glad you don't have to remember it. So it does all of this cunning jiggery-pokery by means of M2F, a very simple object there. And as I say, that will convert your MIDI note number to a frequency, and middle C becomes 261.62558 Hertz. Notice if I hit the A above middle C, we get 440, which is the A above middle C. So that's very straightforward, and then you simply send that value into the cycle object, which will give you the appropriate frequency, and that then is going into a multiplication object which is controlling the amplitude, which is what I'm coming to now. So on the right hand side we have the velocity output, which is going to be a number between, as we saw, 0 somewhere down here and 127, which is somewhere up here. And that is running through an object which is dividing the number, whatever number it is, by 127 point. So why is it doing that? Well, once again, I'm going to go back to our multiply example and remind you that our values need to be between 0 and, or sorry, 1 and -1 in order to fit within our available digital bandwidth. If it goes beyond that, if you remember, it clips. So multiply everything by 1 in this case, everything is coming between 1 and -1, multiply it all by 1 and we fit within our available bandwidth. If I multiply it by more than that, we start to clip. Well, our MIDI values that are coming through are 1 or 0, well, 0 to 127, which means only between 0 and 1 are we going to get values that aren't going to clip. And in fact, if we were to multiply, if we were just to use those values raw and send them into a multiplication object, then we could conceivably multiply our output by 127, which you will notice yields something very close to a square wave. So we're going to be very, very significantly distorted if we simply multiply by 127. So we divide everything by 127, which yields values between 0 and 1. So that means if I send through the number say 127 or something close to it, we get values that are 1 or something close to 1. And if I send through a number close to 0, we get a value which is close to 0. And if I would send something like 64, somewhere around there, then we get something that's close to 0.5. So we map it very simply to a range between 0 and 1, and that of course means that we're not going to clip our data. And that runs through our our gain object and gives us values that are appropriate. So if I hit harder, then I get louder. If I hit quieter, we get quieter. And of course the pitches are appropriate too. So that is that part of the exercise. Let's see how we're doing for time. 6 minutes. So what we might then want to do is to ally that with our enveloping, because at the moment of course the sound is just ongoing, which is, you know, a bit annoying after a while. So I'm going to turn the volume down and shut off the DSP just for the moment and say, okay, well, how would we then ally that with our enveloping function? And we do that by, well, adding that enveloping function to the patch. And what I'm going to do is I'm going to put it in between the cycle object and that multiplication object. I'm going to put in another multiplication object. So in fact now we have 3 means of controlling our volume. So we have this multiplication object, we have the next multiplication object which is dealing with the value, sort of a proportion, or relative proportion of the velocity value that's coming through here, and we have a gain control down here. So 3 means of controlling our loudness. And so if I use that multiplication object and along with a function object, which I'll squeeze in here, which isn't going to be very neat, is it? Let's rise that up a bit. And a line object, or line tilde. Neaten it up a bit. And then we just need a means of triggering that function object. So now, what happens if I draw in an envelope? We have the envelope being triggered, and that deals with the value that's coming out of, or the samples that are coming out of the cycle object. So it gives us our basic wave shape. Then that runs through a multiplication object which is dealing with the velocity value, which means that if we hit the key hard, then we will get the we will get this shape, and the highest point of that shape, so up here, would be somewhere close to 1. So it's going to multiply everything by 1, and therefore it's going to be quite loud. If we hit a key softly, then this shape, although it's the same shape, will run into here, but it's going to be attenuated because this is going to be multiplied by less than 1. So equivalently, this high point would only come to sort of something like this, and then down, and then along, and then down. So we you know, again, the overall shape is the same, but the overall amplitude is not. And then we have the gain control again, which dictates our overall volume. So now if I hit the C key, oh hello, oh it's because I haven't turned it on, there we go. There we go. So now we have a different, so depending on how hard I hit the key, we get the same overall shape, but at different overall loudnesses. I've indicated an alternative to that here, which I invite you to sort of explore. It uses our set range to determine the loudness of the envelope based on the kinds of things that I was talking about